Good morning, everyone, and thank you for joining in our 25th successful webinar. We have started, and so far, because of your continuous support, we are now up to our 25th webinar. Okay, so let's get into our today's topic, that is Gigabit database fundamentals. Okay, and about myself, I am Aakash. I'm the database reliability engineer in Mydbops. I have worked on MySQL and currently handling PostgreSQL team in Mydbops, and also working on distributed systems like Yugabyte and Greencom as well. Also, I have certified professional in both all the databases which I'm handling, especially in MySQL and PostgreSQL. And also, I have I'm frequently speaking in meetups and also written many interesting topics of blogs in all these databases. And it's about our company, Mydbops, which is founded in 2016 as a two-member team. It is started in the motto of providing services to top open source databases like MySQL, MongoDB, and PostgreSQL. Now we have grown and we have more than 90 plus members in our team. And so far we have visited more than 500 plus customers across the world. And also we are proud to say we are certified AWS partner, ISO and PCI certified organization. And types of services that we are providing in Mydbops is database consulting services, and another one is managed database services. Database consulting services where we work on particular engagements like fine tuning the database or architecture changes or taking the audit of the database and so on. And managed database services, which includes the completely taking care of the databases with continuous 24/7 monitoring and the endless number of tasks. Yeah, as mentioned earlier, right now we are focusing on MySQL, MariaDB, MongoDB, and PostgreSQL, and also its related ecosystem, including load balancing or clustering technologies as well. Yeah, so in our today's topic, we are going to discuss about Yugabyte, of course. And before that, we need to see what is the problem with the existing databases. What are the problems or challenges we are facing with the current database solutions, which are mostly used in the market. And then we will see about what is distributed SQL. And then we will see about the YugabyteDB architecture. Yugabyte is a perfect example of distributed SQL. And we will have a small demo of how the YugabyteDB is working and it's maintaining its HA as well. Okay, so let's see what are the problems with traditional databases. So traditional databases here means that monolithic databases, which you are using for very long time, still in since 2000, like MySQL or PostgreSQL. Many databases are Oracle, MS SQL. Okay, and if you are seeing in the application stack, there are a lot of changes has been made in the recent years because of the enormous growth in the cloud environment. We are using Kubernetes and we are making lot of changes and doing lot of deployments each and every day or every week to make the application up and live and to survive in the competition. And also we are getting lot of data. We are consuming lot of data than earlier in this cloud environment. Okay. And for the application scaling, we are effectively using the cloud infra. And in case of any traffic, our applications are able to scale the nodes. In case there is any huge traffic, it will add the nodes and able to handle the traffic of the sudden database, sudden traffic. But if you see the other side, that is the most important thing in the stack is database. And there is not much changes. Okay, we are on cloud infra, but we are not that much using the cloud infra for the database side because there is not much changes made in the database in the last few years. Definitely, there are a lot of features has been added, but not drastic when compared with the changes in application. Okay. So mostly the problem with the monolithic databases that we are using is mostly on the scaling. Okay, we are able to scale the application, but we are lacking to scale the databases in terms of writes. Okay, of course we do have a cluster technology like InnoDB cluster or Patroni cluster for MySQL and PostgreSQL respectively that are able to scale the reads, but still we are lacking on scaling the writes on these traditional databases. Okay, so if you are classifying the traditional databases, we can classify into three types. Okay, we can say it as traditional SQL and NoSQL and NewSQL. Let's see one by one. Okay, traditional SQL. Yeah, popular examples Oracle, MySQL, PostgreSQL. By definition, they are relational. It means that they use tabular format, they support foreign keys, joins, everything. Everyone use these databases mostly. Okay, the major advantages of these databases is it supports ACID property, and also it is very strongly consistent data, which provides. Okay, the major problem we can say with these databases is we can only scale vertically. So vertically in the sense, in case if you are having huge traffic upcoming, you need to increase, you need to support your database to handle the traffic, means you can have only one option, that you need to increase the RAM or CPU of the particular database. Then only you can able to serve the particular traffic. Okay, the problem is, every cloud provider or on-premise, we are having top limit to upscale our instance. And also we need to spend a lot of money to upscale our instance. That is one of the major drawback with these traditional databases for scaling the writes. And yes, another problem is serving writes on only one server. Okay, we can't write on multiple servers. Perfect example is PostgreSQL cluster with Patroni, we can say. So we can always write on only one server, but we can read from multiple servers. But mostly we may be saturated with our writes. Okay, in case of any failures of write, we need to fail over to the another server. It may take couple of seconds. That will also cause downtime. And another major problem is the size of the data. As I said earlier, today we are consuming lot of data. Okay, we are getting lot of data from every applications, every mobile applications, everywhere to analyze it. Okay, but if you are considering the database size, right, it is keep on increasing, and we need to spend lot of time for lot of money for storage as well. Okay, so if you want to distribute your data across multiple servers, there is no inbuilt solution like sharding available in these traditional databases. Okay, so if you want to achieve sharding, you need to go for manual sharding. Manual sharding means that we need to make our rules to hit for the particular IDs, go to the node A, and for the other set of IDs, go to node B, which is difficult to prepare it and also difficult to maintain as well. So these are the general problems we are having with the traditional SQL. And next to traditional SQL, we are having NoSQL. The popular examples for NoSQL is MongoDB and Cassandra. So while it was developed, it was said that it was an alternative to the SQL databases. And also, when compared to SQL, it is having very good horizontal scalability. It means that it supports sharding. If you are having one table, you can split your data for a single table across multiple servers. Okay, and also we can write on multiple servers as per our needs. There is no problem in write scaling here, but it is having some other issues. These traditional NoSQL databases, for example, no ACID guarantee. I get to know that recently MongoDB is having ACID guarantee, but we can't compare those ACID with the SQL databases like MySQL or PostgreSQL. And also it is having lack of multi-key access patterns like joins and those kind of foreign key constraints is not possible in these databases. And in CAP theorem, it's on the availability and partition side of the CAP theorem. It means that it focuses mostly on the availability in case of any partition, network partition happen, then compared with consistency. If your application relies on consistent data from the database, means then this may not be your suitable database. Okay, mostly every databases, every organization uses two kind of databases. One is SQL to save their most consistent data, most important data, and NoSQL to have the least and okay to have non-consistent reads. Okay, this kind of databases they will be using. And other than this, we are having NewSQL. NewSQL is nothing but a modified version of the SQL databases. First flavor we can say is Vitas and Citus. We can say Vitas, it's actually a top layer or wrapper of MySQL with sharding technology. Okay, it is also having a very good sharding solution, but it is having one disadvantage. And also we have NeoDB and OldDB as a NewSQL example. So problem with this is geographic data distribution. Let's say if you would like to distribute your data across multiple zones or multiple region, means it is quite difficult to achieve with this NewSQL method. And also NewSQL method, if you are adding more number of nodes, the performance might degrade. Okay, so far we have seen about what are the problems with the existing SQL databases. Now we will see what is distributed SQL and how it is helping or overcoming all these issues. Okay. First, distributed SQL database. So from this diagram, we can see it is a form of cluster. Okay. It is a single logical database, but in backend, it will like a cluster of servers will be there. And it supports SQL API. There is no need of to learn any new language, SQL language, or any other languages, or no major changes in application. Whatever the SQL database supports, distributed SQL also supports the same. It is having SQL API and automated distributed data storage. If you are writing tables, it will automatically distribute the data across the multiple servers. No need to have any kind of manual uh, functions or manual conditions to do that. And distributed query execution. And also it provides consistent replication as well as the ACID compliances as same like the SQL databases. Okay, this is the characteristic comparison of distributed SQL with the SQL database. Here characteristics we can say first language. SQL database uses SQL language and NoSQL is having custom, and distributed SQL supports both SQL language as well as the Cassandra query language as well. If you like to have SQL, you can connect the particular port. And if you want to have Cassandra query language to use, then you can connect and you can use the database. Okay, you are going to have single database, but it supports both the things. Here, distributed SQL, we have added as an example for Yugabyte only. And schema SQL, we know that relational database and NoSQL and distributed or multi-model one. And scalability SQL, we are having problem of vertical scalability. We can only scale up vertical. There is no option for horizontal, but NoSQL and distributed SQL, we can scale it horizontal as well. And consistency in SQL, we are having very strong consistent, same like distributed SQL, but NoSQL, it is eventual. Of course, it is evolving, but it is not up to the mark of SQL and distributed SQL. And availability, SQL, it is low because we are having single point of failure for writes. But on NoSQL and distributed SQL, we can write on any server and we don't have any availability issues. Okay. And distributed databases, we can scale out. Scale out in the sense we can expand it horizontally. Likewise, we can say currently your cluster is having 3 nodes, node 1, node 2, node 3, and you are going to have any upcoming sale. You would like to increase your cluster resource means you can just add node 4 or node 5. Okay, you don't need to any upscale your instances, you can add it. And once the scale is completed, you can just remove those nodes from the cluster. So this is the option called horizontal scalability or scaling out the database. And another feature is we can write down any nodes. There is no limitation here. There is no replicas kind of thing. You can just write down any nodes. It will accept the writes and replicate across the cluster. And tolerate to failures to any nodes in the cluster. We are okay to lose any nodes in the cluster. Let's say we are having 3 nodes. We are okay to lose any 1 node at a time. And if we are having 5 nodes, we are okay to lose 2 nodes at a time. The reason is we need to keep the majority up and running. Okay, here the 3 nodes majority is 2, it should be up and running. And for the 5 node majority is 3. If you want to have more high availability, you can increase the nodes accordingly as per your needs. Yeah, so perfect example for distributed SQL is YugabyteDB. Okay, YugabyteDB is an open source database which can be used for any kind of applications. If you would like to have features like document store or sharding, automated sharding, and the ACID properties and distributed consensus replication, you can absolutely go for the YugabyteDB, and it is completely open source. It is available in containers or Kubernetes, and so also it is available in per packages based on the Linux systems as well. We can just download and configure it. And it is almost same like the Google Spanner. The major difference between Google Spanner and YugabyteDB is the consensus the algorithm, because in YugabyteDB it is used RAF, whereas in Google Spanner it uses backsource. Okay. In CAP theorem consistency means that we know that every read receives the most recent write or an error. We should not read we should not get any inconsistent data. And availability, every request should receive an response. And partition tolerance, in case of any network drop or network issue between the cluster, system should be able to handle it and continue. This is called cap theorem. We all know that in cap theorem, as I mentioned earlier, NoSQL uses availability and partition tolerance, but Yugabyte uses consistency and partition tolerance. And also it supports high availability to the some extent. It doesn't mean it won't, it will ignore completely high availability. No, it supports high availability based on the number of nodes available. So we can able to achieve consistent and partition tolerant database as well as the high availability to the some extent. And architecture of the Yugabyte is almost same like the Google spanner. Okay, and split branch scenario. Split branch scenario is a term that we use in cluster or distributed system where we are having multiple servers. Okay, in case of this issue actually occur in case of any network drop between the between the servers. Okay, what actually will do, how the YugabyteDB handles the split branch scenario is it will elect a new leader based on the majority. Okay, consider you are having two nodes in Mumbai and one node in Bangalore. In case if any network drop between Mumbai DC and Bangalore DC means, okay, automatically election will happen. Election will start to happen, and in case of Mumbai region, there the majority achieves win, and it will automatically win. And Mumbai region forms here another cluster. And if you see it in Bangalore, it is having only one server. It is unable to achieve the or reach the lead, I mean the majority, so it will shut it down. It won't accept any kind of it. So by using this mechanism, we can exist only single leader is exist through the entire system. In case if this is not possible, what will happen means we start to write down both the DCs and it may lead to the split branch scenario. But it is well handled in the Yugabyte database, so we don't need to worry about split branch scenarios in the Yugabyte server. And the algorithm, consensus algorithm in YugabyteDB is Raft consensus algorithm. It is equivalent to Paxos in case of fault tolerance and performance. Okay, we are using Raft consensus algorithm in these cases like tablet pair group selection and master servers. We will see about tablet pair group and the master servers in our upcoming slides. Okay, key components. Nodes, we can say it as a servers. It may be servers or VMs, or else it may be a containers as well. And group of nodes, we can say it as a cluster or else universe. Primary cluster, which is actually accepting the writes, and re-replica clusters also we can spin it up, and we can keep the re-replica clusters on different availability zones to avoid application latency. And we need to have minimum 3 nodes to form a cluster. Okay, so replication factor means that depends on how many nodes in the cluster. Let's say replication factor, if you want to have 3 replication factor means your cluster should have 3 nodes. And also replication factor should be always a odd number. The reason is that is the case we can achieve the majority or maintain the quorum. And within the primary cluster, it will be always a synchronous replication. This is to ensure there is no data loss happens in case of losing nodes within the cluster. And asynchronous replication is performed between replication from primary cluster to the re-replica cluster. Okay, so now let's see about Yugabyte architecture. This is the architecture diagram for the Yugabyte, which is available in the Git as well. Okay, so here application clients uses distributed SQL API to connect to the database, and also we are having one more client that is called cluster administration. By using the cluster administration, we can see the status of the cluster in browser as well. We will see it in the demo. And each and every node will have 2 processes running always. One is YB master and another one is YBT server. Okay, YB master, which is responsible for managing the sharded metadata, like where location of the tables and the location of the shards, everything will be stored in the YB master. And YB tablets will actually stores the sharded data as well. Sharded data is called tablets here in YugabyteDB. And we can scale, increase the nodes as per our needs here. And YP master should be always odd number. If you are having replication factor 3 means YP master should be also installed on 3 servers and set up on the 3 server. But there is no such cases for YBT server. we can have more than 3 for YBT server. We will see in detail what is YB master and YBT in our upcoming slides. Okay, first YQL layer. It means that Yugabyte query layer. It is having two APIs running. One is YSQL API and another one is YCSQL API. Okay, if your application is mostly on PostgreSQL or SQL API dependency, you can use the YSQL API to connect to the database. And if you would like to have YCSQL, or if you are using Cassandra query language, then you can use the YCSQL query language. Both are running on different ports. For example, YSQL API is running on port 5433. Yeah, and YBT server service. Okay, what is the responsibility of YBT server service, which is running on every nodes? It is responsible for input or output for the application. It means that it is responsible for getting the user request, and also it serves the data back to the application as well. Data, as I mentioned earlier, data for a table is split or sorted into multiple sizes. That is called, we are saying it's tablets in the Yugabyte, and each tablet will have copy of one or more. For example, if you are having your table is having 2 tablets, it will be stored on multiple servers, each copy, because in case of we are losing one server, it will take the another copy to serve the data. That is the basic agenda, to have multiple copies to maintain the HA. Okay, this is the architecture of YBT servers in each and every nodes. So each and every node will have YBT server. It will be having YQL layer, that is Yugabyte query layer, which will be having 2 APIs, YCSQL and YSQL. And you can see tablets are stored in each and every nodes. Okay, all the tables which will be splitted in the form of tablets, and it will be placed on all the servers. And let's say your replication factor is 3, means your tablets will be placed on the 3 servers. Okay, for this example, my replication factor is 3. Okay, you can see it in the diagram. For my tablet 16, it is placed on node 1, node 3, and node 4. Okay, let's say in case my node 4 goes down, okay, and what are the data reading from node 4 will be redirected automatically either to node 3 or node 1. Okay, that is the way we are achieving HA for each and every tablets. Okay, this is not only for single tablet. Whatever the tables we are creating, which table may have n number of tablets, for all the tablets it will be placed on multiple servers, depends on our replication factor. Okay, next to YBT server, another very important process that is called YB master service. Okay, what it will actually have means it will have the metadata and records of the each and every databases and tables. Okay, if you are having any tables, it will hold the record of the location of the table as well as the where the tablets are located here. And it is also for responsibly coordinating the background operations like splitting the tables and all. This is the architecture diagram for YB master service. You can see node 1, node 2, node 3. We are having YB master. Okay, each one will interact with each other YB master and forms a raft group. Okay, one of the member will be promoted as the leader and remaining will act like a follower. YBT server will always send the heartbeats to the YB master. Okay, this is the diagram that combines both YB master and YBT server. And we can, again, I am saying we will be having YB master on odd number of nodes, that is equal to our replication pattern, and YBT server will be having more than number of nodes than the replication pattern. For example, here 3, we are having 3 YB master and 3 greater than 3, that is 4 YBT servers we are having. Okay, but the tablets on the YBT server will be placed based on the replication pattern only. Here we can see my replication pattern is 3. It is not placed on all the 4 nodes. It placed only on the 3 nodes. That is the way it is holding all the data. Okay. So next to YB master, we are having some core functions. So first step, if you like to have Yugabyte running on your system, these are we can say that is a universe creation or cluster creation. First, we need to start the YB master. Sufficient number of YB masters should be started. It means that you're equal to the replication pattern. If your replication pattern is 3, it should be like sufficient one number. And YB master service will be running like each one will spin up your own UID will be there. Okay, and it performs an election. As I mentioned, each will start and performs an election. One of the master will be established as a leader, like mentioned here. Okay, each one will forms a raft, and one of the cluster will be makes as a raft leader. This is the way it forms a cluster. So this is the command to create the universe. Okay, YB master, we will be having master addresses, master 1, master 2, master 3 addresses will be given, and cluster create. It will create a cluster, and one of the server will be elected as the leader using raft, and all the YBT server will send the data bits to the YB master leader only, not to the followers. Okay, next step of the cluster creation, we can say it as table creation. Okay, well, these are the steps we will do by the YB master for each and every table creation, and table creation step is owned by YB master only. It will only create the table and assign the tablets to the YBT servers accordingly. So first it will validate the data, then it will replicate the data across all the servers. It means that YB master, and once it gets acknowledgement from the other server, then only it will start the execution. Okay, here is the example. So we are creating the table. Okay, first it will hit the YB master leader. Master leader, what will do? It will first validate the schema, and based on the schema, it will create tablets. Okay, and then it will send the data, these details to all the YB master, to the majority mostly. And then once we got okay from the majority, it will start to create the tablets on the YBT server. So why it is doing these things means, in case while we create the table, if you lose the node 3, that is our YB master, means we can still continue that process by using node 1 or node 2. That is the reason it is replicating the data to all the server immediately. Once we got the majority, YB master will create the tablets and assign across YBT servers. So it will create, let's say my table, I'm creating one table and it is having 16 tablets, means it will create all the tablets across the all available YBT servers. Okay, and one more interesting thing is, each and every tablet will form a raft group. Not only YB master, each and every tablet in the YBT server will form a raft group. Again, let's say my this table is having 16 tablets, tablet 1 to 16. Tablet 1, all the 3 nodes of my replication pattern will connected and forms a raft group. Tablet 2 will do the same, and up to tablet 16 will do the same. Why it is doing means, we are writing on one node, it should have high availability, and it should have replicated data to all the available servers. Okay, in case we are losing one node, we should be able to up and running. That is the reason for so many raft groups. Okay, now we can see how the write IO is happening on the Yugabyte. Okay, first actual thing is user write request interact with the YQL query layer. It means that our MySQL API or else MySQL API user request will be translated into an internal key by the query layer. Okay, based on the internal key, we know that each location will be handled by the different tablets. YQL query layer doesn't have aware of the location of the tablets. What it will do, it will make a call to the YB master to determine the location of the tablet. YB master will send the details to the YBT server. Then YBT server will place the write on the appropriate server. So YBT server. That is the MySQL layer. Then finally write the data on the appropriate server. This is the example. Here we can see what we are doing is, we are issuing user issued query, that is insert into, we are making it, and it will be first handled by the MySQL query layer. MySQL query layer, what it will do, it will reach the YB master leader, and it will get the data or what is the location of this particular record. Okay, and let's say tablet 2 is my record, means what YBT server will actually write the data on the tablet 2 leader, not on the followers. Once it is written on tablet 2 leader, it will automatically replicate to all the peers, majority of the peers, based on the raft group. So this is the way actually write is happening on the Yugabyte, and it is maintaining its hierarchy for each and every records that we are making. And similar to write, the read is also almost same. Okay, it will be handled by YQL layer. YQL layer will get the data from the YB master, and finally YB master issues the location of the location of the particular tablet. Yeah, so select query we are firing, and it will be handled by the YQL query layer, and it is sending data to the YB master to asking where the location or what is the location of this tablet, and it is pointing the data to the particular tablet. Then it will get the data from the YB T server particular tablets leader and send the result to the end user. So this is the working mechanism of both read and write in YugabyteDB. Okay, now we are having multiple components, and we know that how the YB master is maintaining high availability and YBT server is maintaining high availability as well because of the by forming the wrapped group. Okay, now in case what will happen if there is a YBT server goes down? Okay, what are the things can go fail? YB layer, YQ layer failure. Yes, of course it will be failed, but won't be an impact because we do have remaining servers running, so we can connect to any other servers. And Y tablet pair follower failure. Just the followers on the particular YBT server will gone fail, but it won't be an impact to the application because we are not doing anything from the follower. So far we have seen whatever the operations we are doing, it is from the only from the leader only. And finally, tablet pair leader failure. It is means that in case of leader failure, it will another server, another YB3 server will take the leader role, and we can start to get the data from the new leader. So this is the way YBT server failure is handled by the YugabyteDB. And in case of YB master, we know that YB master is not doing any kind of IO operations. Everything is handled by YBT server only. Okay. In case if we are losing the YB master, what actually happen means another YB master will be promoted as the new leader. So our YBT server will get the data from the new YB leader master. Okay, actually it won't cause any kind of issues. So until we are on the majority of the nodes, we are safe. For example, 3 nodes, if you are losing 1 node, you are running on 2, you are good. If you are losing 2 nodes, then we will be having issues. Okay, and these are the some of the default ports. For example, if you want to connect MySQL, or else if you want to have PostgreSQL compatible Yugabyte, you can use 5433. Or if you want to have Cassandra query language, you can use 9042. And YB master intercommunication across the remaining servers means it will use 7100, and YBT server it will use 9100. So if you are forming a cluster, please ensure 7100, 9100 are open across the cluster. Then only YB master can communicate or YBT server can communicate with other servers, and then they can perform the cluster operations. And if you like to have graphical admin user interface over the GUI, you can use YB master admin UI or YBT server admin UI. It can be accessible from 7000 and 9000. These are the default ports that is available. Okay, now let's see a small demo. Okay, so here we can see this is the YB master admin portal, which is running on 7001 on my cluster. And this is the 9000, which is the YBT server admin portal. You can get it on the admin browser itself, all these details. Here we can see my universal UID is this one. And for my cluster replication factor is 3. And the number of T server nodes I'm running 3. I'm having 4 user tables. That was what it is showing, 4 user tables. And it is showing Yugabyte version as well. And here we can see YB master server details. Okay, this is my master YB master leader, and it's uptime everything. And YB follower, these are the other 2 are the followers as well. Okay, and if you like to see the number of tables, you can just click the tables name. You can see these are my 4 tables. All my table states are running. If you are clicking the particular table, it will say the table structure and the replication pattern, number of replicas, replication pattern, and also it will show the each and every tablet detail as well. Okay, here for this table, I am having 3 tablets. For this table name, what is called products, test.products, I am having 3 tablets running. Okay, and this tablet is my leader. This tablet is my leader for this one. For this particular tablet, this is my leader. And for this tablet, 0.4 is my leader. And for this tablet, there are three my leader. Okay, each and every tablet is having a leader and also having a follower. And you can click the namespaces here. Namespaces is nothing but the database name. The test is my database name. And tables we have already seen. And tablet servers. Yes, these are my tablet servers. And all the status are up and running fine here. Okay. So this is the YBT server admin portal, which is almost same like the YB master. Okay. Now we will see in the cluster. Just a second. Okay. So this is my cluster. Here I can see I am running it on the container. You can run it on container or else on different VMs or different physical servers. It's upon our need, based upon our needs. Okay, here I can see I am running three containers. These are forming a cluster. Okay. So this is my, so by default it is connecting to the YugabyteDB and I am using the port 5433. I am using the PostgreSQL SQL language. Okay, my database is test. I'm connecting to the test. And I am having 4 tables. Okay, now let's try to run this query. As I mentioned earlier, we can run query on any of the servers. Yes. Yeah. Okay, so now let me try to stop the one of the container. Let's try to stop the plus node 3. Okay, you can see we are still getting the response from the cluster. Even I have stopped one cluster because I am succeeding in the majority now. I lose to only one server. I have still 2 servers running. Okay, and also we can see the cluster status in here as well. You can just refresh the page. See, you can see my cluster is, my particular node is down, but we still have both the leader and one follower running. And also you can see here as well. Yeah. There you can see the tablet time since orbit is increasing on this one. So it will mark it as dead. Yeah, it marked as dead. Okay, so now let's do one more thing. We will stop the another one server as well. Now we will lose our majority. We know that. Now we can't query anything. Our cluster will be unresponsive. So we should be able to maintain the majority. Okay. See, even my UI is also not working. It is saying unable to locate the leader. And all because right now we don't have any leader because we lose our majority, all our nodes are down. Okay, let's start the cluster back. Yeah. So once we have the majority available, we are back live. Yeah. And let's see, we are able to query the data. Yes, we are able to query the data as well. Let me start the node 3 as well. Okay, my all the tablets are available and also my all the master is also available. Yeah, this is the way Garbet is handling the data and the high availability. Yeah, that's it, guys. Thank you. Thank you, everyone.